All right, so here we go. My name is Patrick Stumpf. This is my project. Basically, what we're going to be doing is a problem that's much like the one we did in class, only it's going to have a little bit of twists and turns and whatnot. I'm leaving my hat on because I have some serious crazy hair, and it is pretty early in the morning right now, so this is my third take, but here goes nothing. So basically what we have is we have a wall, and then that's going to be fixed, and then instead of the one piece of steel or whatever we did in class, we have three different pieces. So we have three that are all going to be at the same length. And what's going to happen is this one is going to be bronze, and then these two are copper on the outside. And then this is also fixed at the bottom, should be connected. Fixed by another wall. And then basically what's going to happen is then you're going to have lovely bolts coming down, and the bolts are going to connect this in tension and be pushing down on that, which will even everything out. So basically what we have overall, and these things are made out of steel, just before I mention that. And then basically what I'm going to try to solve for using everything else is going to be the change in the length of the steel bolts and how much they're decreasing size when they're in tension. So ds is going to be equal to question mark. So then for our first equation, we just need to find the sum of forces. So right here we have F of S is what I'm going to call it, the force of the steel. Right here we have F of C, force of the copper. Right here we have F of B, force of the bronze, and then it's the same thing only flipped on the other side. So we have another FC and then another F of the steel. And basically, when we do that, basically what's going to happen is then we're just going to sum up everything. So right now we have our first equation is going to be 2FS plus 2FC plus FB is going to be equal to 0. And that's just saying that all of these, when they're added up, they're going to equal 0. So that's going to be our very first equation here. And moving on. So then we're going to go to our second part of it. And then we're just going to break down the forces a little bit more. So we have F of S is going to be equal to KS times delta S. And that's going to be A. And then we have B is going to be equal to FC is equal to KC DC. And then we have C, which is going to be F of B is equal to KV delta B. So there we just have everything broken down a little bit farther. And then we need to find the compatibility equation. And what it's looking like right here is we have the equivalent of, so for compatibility, we have a total of L minus S plus DS is going to be equal to L plus DC is equal to L plus DB. And then this equation is simply from something that looks a lot like this, which we're going to go over here and do quick. But basically what's happening is the initial thing. We're going to have all three of these, three of the blocks or whatever, put in this position, and then we have our bolt, and then this is basically the instantaneous version that we did in class or whatever. But basically what's going to happen is we have this is equal to L, this length right here, and then this little gap right here is going to be equal to S. So for this, it's going to be, for the steel or whatever, it's going to be L minus this little S is going to equal this length. And then this is going to equal to, then we have the DS that's happening as well. So the change in S when these goes down. And then L plus DC is going to be, or whatever we have here, DC, and then DB, so, or delta B. So basically those all add up, and that's our compatibility equation that you see right here. Also of note, didn't mention it earlier, but we have N is going to be equal to 2 in this equation just because it's a nice number and it'll work out great. But my computer just paused right there. Okay, so now we're good. But basically, so for another quick little side equation, we have the S is equal to NP for bolts. So our S is going to be equal to 2P at this point in time. So that's what we have for our S length. So moving on, we can kind of work with these and cancel these out. So we have L minus 2P plus ds is equal to L plus dc, and this is simply taking that S that we found over here and plugging it into the S there, and then we can have the L's cancel out. So at this point in time, we have the same thing, only it's L minus 2P plus ds is equal to L plus dB. So both of these go about the same thing, and the L's cancel each other out, which leaves us with negative 2P plus ds is going to be equal to dB, which is going to be the same for copper. So we have negative 2P plus ds is going to be dC. And we're going to call that equations F and G. And then this one up here, the S equal 2P, we're going to leave at E. So those are basically all the equations we have. And then basically what happens is we're just going to take those and put these that we found right here back into these, back into there. So we're just going to go about solving the entire thing here shortly and move on with it. So for the solving part, we're taking these and putting them into there. We have F of C is equal to KC, which is equal to negative 2P plus ds. And then we have F of B is equal to KB minus 2P plus ds. And then we have F of S is going to be equal to KS delta S. So those are the three. And then if you take these equations that we got from here and plug them into the original number 1 equation, so this is plugging into 2, 3 into 2. Now we're going to take these, take this 2 and move it into 1. So we'll dot the line right there. And moving it into 1, we have 2 KS delta S plus 2 KC negative 2P plus delta S right there. And then we also have added onto that, we have KB negative 2P plus delta S once again. And then that's going to be equal to 0. So from there, we can start solving for ds because we have everything in terms, or ds is the only delta that we have here. So we can take everything and make that into just one big formula here. So moving forward, this becomes 2ks delta s minus 4kcp plus 2 delta s minus 2pkb, that's a bigger k, and then that's plus delta s kb. So yeah, so there's another version. Summing this down a little bit more, we put all the DS's, which there are 3 of them, on the same side and move everything else to the other. So at this point we have 2ks delta s plus 2 delta s plus delta s kb is equal to 4 kcp plus 2 kbp. And then we just take the ds's out of here. So ds is equal to 2ks plus 2 plus kb. And then that's going to equal the same thing we just had. So 2kcp plus 2kbp. And then we're just going to divide by this right here. So ds over all is going to be equal to 4 kcp plus 2 kbp over 2ks plus kb plus 2. So overall, that's our final equation for ds. and it should be right because I had other people look over it, so I'm hoping it is. It'll also be in the homework. So that's a statically indeterminate problem. It's pretty self-explanatory. It's been like what we've been doing, so should be pretty okay to understand. Everything's right here. So that's pretty much all I've got. That should be it. Thanks for watching. All right.